we are going to look today at exactly why the cognitive system is ideally suited to helping you visualize data. My name is Andy Cotgreave. I'm technical evangelist here at Tableau. I've been working at Tableau for over 7.5 years. I've been using Tableau for 10 years, and I've been building dashboards and data visualization for about 12. Last year, I co-authored or published a book, The Big Book of Dashboards, which I co-authored with Steve Wexler and Jeff Schaefer. And I'm just really excited today to be sharing some of the knowledge that I've gained about the fundamentals of what we do when we analyze data. So to start off with, before we can even answer any questions, one of the really important things to do is to think, anytime you're analyzing data and then sharing it, you've got to think, who is your audience? What data literacy do they have? What chart are you building for them? What questions do you have? And what is the purpose of any chart you're building? So we're going to go through the science behind data visualization and how that applies to data. But we have to think about the purpose. Whenever you visually analyze data and then share it in data visualizations, you are trying for the largest number of people to provide the greatest degree of understanding, but while requiring the least amount of effort from your audience. That's the goal. With that goal in mind, we're going to look at the cognitive system and how the eye and the brain work together to help us see and understand data. Then we're going to see how the particular aspects of that combine to allow us to build charts. And then we're going to talk about the most appropriate charts for certain different purposes. It's a great foundation for the rest of the webinar series. So our cognitive system, this amazing system given to us by millions of years of evolution. Our minds are wired in a really specific way. The wiring helps us to see the environment around us, but it also plays tricks on us. Our brain is working extremely hard to focus just on what it thinks is the most important thing at hand. Now, we can't stop the brain doing what it does. That's how we evolve. But what we can do in data visualization is learn to avoid the pitfalls and focus on the absolute benefits that our cognitive system has. Let's take a look at two examples of some of the weaknesses in our cognitive system. And these are the pitfalls we need to be wary of when we're visualizing data. First of all, it says put your hand up when you see the toothbrush. You don't have to put the hand up. Obviously, if you will do that in your offices, that would be quite funny. But I'm going to show you a picture. When you see the toothbrush, physically or mentally, put your hand up. Can you see the toothbrush? Now, already, I'm sure most of you have seen a toothbrush. But how many of you have actually seen two toothbrushes? So here's a toothbrush. That's probably the one most of you have seen. But I suspect a lot of you have not seen this toothbrush, which is enormous and actually dominates the entire picture of this bathroom scene. This is an example of our brain working to understand contextual information and ignoring things that might be really obvious, but we are blind to because we see familiar situations and therefore filter out noise in the background. Let's have another look, something more specific to data visualization. I'm going to show you a picture, and I just want you to think quickly, is there more red, white, or blue? So, which color has the most squares? Is it red, white, or blue? A lot of you, I suspect, will have answered blue. That's certainly what most people would answer when they see this grid of squares. But let's have a look at how many squares of each there were. Here are the white squares, here are the red squares, and here are the blue squares. You can see that there were the same number of squares for each of the three colors. What's happening here is our brain is trying to find patterns in the environment around us. This is a part of a larger theory called the Gestalt theory and Gestalt principles. And in this case, there's a theory of proximity where when we saw the blue dots together in a single coherent group, we actually overemphasize those and perceive that there's more of them. Now imagine if this was real data. This data arranged on a grid, you might actually misinterpret the values just because our brain is trying to find patterns that may or may not exist. So these are the pitfalls we need to avoid when we're visualizing data. The good news is our brain is also, our eye and our brain, our cognitive system, are also fantastic. So let's go to some examples of how and why the brain works so well to allow us to visualize data. So very famously in 1973, the British statistician Francis Anscombe created a special set of numbers which he wanted to use to emphasize the importance of graphing and visualizing data before analyzing it. He was emphatic that while numeric calculations can bring an exactness to analytics, graphs and charts actually show potentially a great deal more. So here's the quartet, 4 groups of numbers, A, B, C, and D. Can you see any patterns in these numbers as you cast your eye over them? It's very hard to see anything meaningful. You might have seen something unusual in some of these numbers. But what Anscombe was worried about was that increasingly people were doing statistical analysis on tables of numbers. And this set of numbers have a very interesting set of statistical properties. If you calculate the mean, the correlation, the variance, and the regression line, all 4 groups have the same properties to within like 100th or 1,000th decimal point. So each of those 4 groups of numbers are statistically the same. That's great. We've analyzed our numbers. We don't need to think about statistics anymore until we plot them. Here is group A, here is group B, group C, and group D. Your brain is wired to see fundamental differences in these numbers in milliseconds, much quicker than you could type this and put it into SPSS or a statistical package. Anscombe's quartet existed to show that if you see the data, you are going to see things as quickly or more quickly that machines cannot detect just via statistics. That was in 1973. How about in 2017? Here's another example from Justin Matejka and George Fitzmaurice. They took a data set created by Alberto Cairo, another famous author in the data visualization space, to see what they could do. This is Datasaurus Rex. Alberto wanted to create a data set sort of similar to Anscombe's data, where it has a particular mean of X and Y and regression and etc. But if you looked at it as just a table of numbers, you would not see that when you plot this information, it actually makes a T-Rex. This is why we visualize data. If you just look at your table of numbers, you wouldn't see the dinosaur. So what George and Moritz did was take the T-Rex and take it one step further. What they created was a Python script that would take any input image, any shape you could input, and create a plot where the mean of the X, the standard deviation, and the correlation were identical to the T-Rex. So what you're seeing here is all those different images they input, and you could have done any of them. Each set of these numbers has the same statistical properties. So what they did essentially last year was extend Anscombe's quartet to much larger data sets. Now, as an aside, think about the increasing prevalence of machine learning and artificial intelligence. We're increasingly being told that we should throw numbers like this into machines and then assume that algorithms will detect patterns and differences and conclusions for us. Well, what this shows is that choosing the wrong algorithms, and like standard deviations and correlations are machine learning algorithms, if we choose the wrong ones, then the models might completely misinterpret what is actually plainly to be seen when we look at it with our eyes. So whatever, 1973 for Anscombe or 2017 with this modern version, humans and our cognitive system are a vital part of the process, and this is why we visualize data. We have to be in the loop using the organs that evolution gave us to see accurate values. Let's take this to some real data. I'm going to show you a table of numbers. Just think which are the biggest values and what are the trends. How is these numbers trending up? So here's fictional data on sales of furniture, office supplies, and technology. When we look at data like this, we will ask business questions. This is why almost all of you are on this webinar. You have business data of which you want to ask and answer questions. So, what's the biggest value on this table? You can find it. It might take a while, but you can find it. Okay, which one of these is which category is trending upwards and trending downwards? Which is the third biggest category in Q1 2014. These are standard business questions. But can you see the answer to the questions? No, you can't. It's very, very hard. But when we put that into a chart, suddenly everything pops out. Technology sales is in blue. That's the biggest, and you can see that was biggest at the start of 2013. All three categories were trending kind of flat throughout the year, but they each had an uptick at the end of the year. Notice how we can compare trends. We can look at ranges. We can spot outliers and much, much more. So not only do we take numbers and make them into charts to make insight jump out, there's another very important psychological concept called chunking that is at play here. If we go back to the table, when you're trying to compare one number against another, you can only memorize, well, a few numbers in your short-term memory. It's possible to keep maybe 5 or 6 things in your short-term memory. Over 7, and we have no chance. So when you put one number in your head, you soon forget it as you look at the other numbers in the table. What chunking allows us to do is actually place an entire line of numbers in one slot in our short-term memory. So on the chart in the bottom right, technology, the blue line, is held in our short-term memory as a single chunk or memory slot. So as we visualize data, we are allowing our short-term memory to contain much more information. Essentially, we are hacking the RAM in our brain, if you want to think of it from a technology perspective. This is why we do it. So once we've understood what we do, or why we're doing it, we can then come up with a definition of what data visualization actually is. There are many different definitions around in many different books. Andy Kirk on visualizingdata.com, he defines it as this: data visualization is the representation and presentation of data that exploits our visual perception abilities in order to amplify cognition. It's as simple as that. We have just looked at the cognitive system and begun to understand how the brain and the eye work together to allow us to see things in the environment. Now we need to start thinking, well, how can we map that power to data itself? So let's take a look at some data. I want to ask you a question. I'm going to show you a table of numbers, and I want you to have a look at the table of numbers and count how many 9s there are in the grid. So here's the grid. How many 9s are in the table? And this isn't a hard question. Any one of you can go across the table and count the 9s, but you have to look at every single digit in order to do it. So I'm going to make one change to the table so that it's easier to count the 9s. You don't have to count them. There are 13. But the point is, all I did was change the color, and now the 9s pop out against the red, or the red 9s pop out against the soft gray numbers. I could actually make another change and encode the data in a bar. So I've aggregated the numbers and drawn a bar chart. Now you can see there are 13 9s, and you can see it was the third most common digit. There were only 5 number 3s. These are the fundamental building blocks and the paths we take to simple and then more complex charts. This obviously isn't real data, but it shows the power we have. In the middle, I used color to encode the 9s. And then on the right-hand side, I used length to represent the number of 9s in the table. Color and length are two of a very special set of features called pre-attentive attributes. So here's 12 pre-attentive attributes. There are more, but these are visual features of objects around us that our brains notice before we consciously look at them. Yes, that's right. You saw the bar was longer, and the width, and this bar was wider, and this circle was bigger. You saw those things before you even consciously looked at the slide. Our brain is trying to look at process the environment around it as quick as it can, so that when we draw attention to particular parts of to what we want to look at, some of the work has already been done. And these pre-attentive features form the basic building blocks for all the charts we might build in Tableau, which sounds great. But knowing that these are pre-attentive attributes doesn't necessarily mean that they're all the best pre-attentive attribute for a purpose. So ladies and gentlemen, we are going to take a quick poll. I'm going to ask you a question. I'm going to ask you to answer 2 questions. So JP, if we could launch the poll, please. Here on screen are 2 charts. One says, based on A, what is the value of D? So on the left-hand side, we've got grey bars. A is 150, so what is D? On the right-hand side, we've got bubbles. Based on the value of F, what is the value of H? And a poll panel should have appeared on your WebEx console. If you could answer the question, I'm going to give you 2 minutes to answer the question. What is the value of the red bar D? And what is the value of the orange circle H? So hopefully you can all see the poll, and we'll have a look at the results in a minute. Johan, you've just asked how this will work on text-based answers. Well, the answers, I've given you bins, so you can only answer in the bins. Okay. So if you answer, if some of you are answering in the Q&A, there is a poll panel which should have appeared on your screen. Hopefully you can all see that. So please type in that there is multiple choice answers. Okay, another 10 seconds, and then we'll have a look at the results. And the poll is closing. Now, JP, if you could share the results to everybody, that would be amazing. And JP, I can't see the results. Oh, yes, I can. Right. Right, hopefully everybody can see the results now. What I can see, this is excellent. Right, what I can see is most people got the right answer for the length of the bar. Looks like 328 people answered 40 to 49. Whereas your answers to the value of the circle are less successful as a group. Looks like a lot of people answered between 30 and 39, and some answered between 40 and 49, some answered between 50 and 59. For those of you who can't see the results, I'm going to show you the results of having done this many, many times with many, many groups. So we've asked over 1,600 people this simple question, and these are the results of what happens when we ask people. The bar is 45. The circle was 35. The red histograms show the distribution of answers that people have given us when we ask these questions. What you can see is that most people find it very easy to fairly accurately estimate the length of the bar. In fact, over 600 people have got the right answer within 5 or 10. But look at the circles. The answers are spread all over the place. In fact, more people have underestimated it than actually got the right answer. 358 people guessed between 20 and 30. The point of this exercise is that as we discover the pre-attentive attributes, we need to be wary of how we use them. Circle size is something we see pre-attentively. We see different size circles instantly. But what we can't do with circles is estimate exactly how big one is compared to the other. Whereas length on a bar chart, we can actually very accurately estimate if a bar this long is twice as long as a bar this long. So when we visualize data, we've got to choose the pre-attentive attribute that is most relevant to the level of accuracy we need our audience to have when they're interpreting the data. So thanks for doing the poll. If you got the answer right on both, if you got both the answers right, congratulations. If you got the circle size right, then congratulations. Let's have another look. A look at another example. It was Halloween yesterday, and in this one, I want to emphasize that yes, circles and some other pre-attentive attributes are really quite bad for accurate interpretation, but no chart type should be banned. There are often reasons when you might use one pre-attentive attribute or another. Here's another example from The Economist, and they published this chart on Halloween last year. It shows data about witchcraft trials between the 14th and 18th century across Europe. Excellent data, right? The bars, so the long horizontal bars, show the number of people who were accused or executed of being witches, and then the circles show the ratio of trials to population. So the bigger the circle, that means more people were being tried relative to the population of the country. What pops out therefore is Switzerland had 980 trials per 100,000 people and actually did accuse and execute quite a lot. So the Swiss really seem to be worried about witches over this time period. Now, I just showed to you, and we proved during the exercise, that circles aren't very accurate, whereas bars are. So why did The Economist make a choice to use a bar to show the number of trials, but only a circle to show the prevalence of trials? Well, they did it for a very good reason. The length is the most accurate way to encode data. And that was the prime message behind this chart and the article that went with it. The article was about the number of trials. Therefore, they used a bar, which is an accurate representation of data. The secondary part of the story was a conversation about how that related to population. And therefore, they used a less accurate way to encode the data because that was not the prime purpose of the article. When you are visualizing data, you've got to think, I have a set of pre-attentive attributes which I can use to encode data. Which is the most important thing people need to see accurately? Then you choose something that's very accurate. And if there is secondary information, then you can, if you need to, use something like circle size. Bar charts and line charts are great for a reason, though. They work, so kind of always lean to the best possible. But it does allow, again, we can play another quick exercise. There's no poll for this one. We just saw there are 980 trials per 100,000 people in Switzerland. Therefore, how many were there in Scotland? And there were 9,800 trials in Switzerland. How many were there in Scotland? Okay, another quick exercise to estimate the different, to see if we can estimate differences in bar and circle size. Okay, hopefully you've come up with an answer. The answer was 509 in Scotland and 3,563 in the trials. What I wonder, it'll be interesting to know. I guess most people will have inaccurately guessed this, and you might have been more accurate on this one. We'll wrap up on pre-attentive attributes by me showing this table and chart. Cleveland and McGill did some of the most fundamental research on pre-attentive attributes. And in their studies, they tested which are the most and least effective for accurate estimates. In other words, which are the best and worst? Which are the best and worst in terms of making effective charts? Let me just go to the top of this chart first. Oops. My slide seems to have stopped. There we go. So at the top of this chart are the most effective pre-attentive attributes. And you can see it is position on common scales. Essentially, bar charts, line charts, slope charts, and scatter plots. They are accurate. As human beings, we can see the differences. As we scroll down this table, we get to chart types that are least accurate. For example, color hue. and shade and volume and 3D size. We can't accurately interpret that. That's why you don't see 3D spherical charts in any quality data viz package. Let's go back up to the top. When you are building charts, when you are thinking about which is the most appropriate way to look at data, you're looking at simple charts. They may be boring, but they're only boring because they're prevalent. They are so effective. A bar chart is a great way to show data. So let's map this to data. We have looked at how the eye and the brain work together. We've looked at these pre-attentive attributes which make the atoms from which we can build charts. Now, let's take some data and build a chart. I confess, I'm in my mid-40s, so I grew up with the Next Generation, best TV series ever, unquestionably. I have data about all the episodes in Star Trek, and we can make a chart and show how we can take pre-attentive attributes and map them to data types. So, we all have data in our organizations, and we can classify data in many different ways. One way is to say we have categorical, ordinal, and quantitative data. Each of those can be encoded in different ways. Let's take some Star Trek data. And what I have is episode ratings for every episode from The Next Generation. Here is some nominal or categorical data, the episode names. So nominal data represents distinct categories of things. I can see a question, are you going to share the Star Trek data? I actually can't share this because we got it from a website called kevinformatics.com, which I think is no longer available, but it was a great show, it was a great website for looking at this kind of data, so check it out, see if it's reappeared, because you can look at all box sets. Thank you for the question, Colin. Now, this is nominal data. Nominal data are categories of things like an episode, or a Starfleet spaceship, or a computer type, or a type of drink. You can't do sums with them, but they describe objects in the world around us. And I've encoded each of these using position. Each one of the episode names has a different position on the screen. It's kind of not relevant. The position doesn't mean anything, but they're all spaced out on the screen evenly. Next, we have ordinal data. Ordinal data is also discrete, but it's a set of data that comes in an order. In this case, season number is ordinal, because you had season 1, which came before season 2, which came before season 7. You can't aggregate these things because you can't have an average season number of Star Trek. Doesn't make sense. You can think of ordinal numbers as the year group of your children. Right? I have 2 daughters. One is in year 7. One is in year 5. I can't say, therefore, my children on average are in year 6, because that doesn't make sense. But year 1, 2, 3, 4, 5, 6, 7, and up to 12 comes in an order. So nominal are discrete objects. Ordinal are discrete objects that come in an order. And in this case, I've encoded my ordinal data using color. So we can see the episode names and all the seasons by color. But we want to actually get some insight out of the data. So I've gone one step further. Now I've used position to encode seasons. So here's season 1, 2, 3, 4, 5, 6, and 7. Kind of meaningless, but now we bring in the data that gives us insight, and this is the quantitative information. So quantitative data is data we can aggregate and do sums on. And what I've done here is show the episode rating, the average episode rating for each episode of Star Trek The Next Generation on a y-axis. So quantitative data is the data we can sum, or aggregate, or do averages and do calculations on, and I've used position on the y-axis to encode the data. So before we look at the insight, we've got categorical or nominal data, which is the episode itself. That's encoded using position. We've got the season, which is ordinal, encoded using color and position. And the quantitative data, which is the rating itself, which is encoded also using position. As a side note, we could have an argument about whether episode rating is ordinal or quantitative. For the purposes of this exercise, I'm saying it's quantitative. but we can talk about that on Twitter or elsewhere if you want to. But we built a chart. Obviously in Tableau it would take you a matter of seconds to build this chart, not 5 minutes. And we can get insight. For example, what's this outlier? It's clearly the worst ever episode of Star Trek. Anybody who is a Trekkie might know it's Shades of Grey, which was the season finale at the end of season 2. The script writers were on strike, so the producers had to cobble together an episode made of clips from the previous 2 seasons. And as somebody said, it's an insult to the audience and my vote for the worst episode of Star Trek ever. I've never watched it, I never will. But the chart gave us insight, and we used position and color to encode our pieces of data. They're the pre-attentive attributes. Let's have a look at another example. Here's a table of numbers, and it shows market share for Domino's and Pizza Hut over a 10-year period. If we were in a classroom, I'd love to get us all with a pencil and paper and some post-its and just scope out some charts that we might use to visualize this, good charts or bad charts. But you can just ponder for a second, how would you visualize this data? Which pre-attentive attributes might be relevant? Well, I obviously can't share with you, can't see the charts you might have thought about, but here's the original chart that that was actually found in the field, and we took the table of information from. It came from the Wall Street Journal, and they did this side-by-side bar thing to show the data. So they've encoded market share using length, and year is in position. And this isn't a bad chart, it's not too bad. You can see the trends between the 2 pizza firms, but is this the best way to visualize this data? The kind of the yellow, green, yellow, green, yellow, green, yellow, green slightly create a bit of cognitive noise that is hard to interpret. So we could think about many different ways to visualize this data. We could use dots and position, and then the length of the dumbbell between the dots, or the length of the bar between the dots, encode difference. So rather than actually encoding the value itself, we're using a pre-attentive attribute, length, to encode the distance between 2 dots, which really emphasizes the convergence of the 2 firms over time. We could do a bar inside a bar. So in this case, the Domino's and Pizza Hut, they both take the same space on the x-axis, which is a valid way of doing it. We can calm the colors to make it a little bit more clear. I sometimes think people interpret bar in bar incorrectly, in that they think the top of this bar is a proportion of the total value, whereas in this case they're both discrete. So maybe that's not great. We could have done the simple line chart. Of course, draw a line chart, because line charts are amazing. We are using position and angle to very accurately represent data. It's highly effective. We could then take the line chart and shade the center to further emphasize the convergence. Some of you might have thought, well, hang on, there's some data missing here. What if we encoded the rest of the market? The orange line represents everything that isn't Domino's and Pizza Hut. And now the pre-attentive attributes and the nature of the data visualization clearly show that while Domino's and Pizza Hut are coming together, the rest of the market has taken over those. If that's the story, because if that's what's most important, we could create a grey line which groups Domino's and Pizza Hut together and just shows other. These are all different examples. One more, the final example on this is, what if we just get rid of all the stuff in the middle? It doesn't really matter, perhaps, what happened in 2008 to 2015. Maybe all I want to know is what happened in the last 10 years, from 2006 and 2017. In which case, get rid of all that stuff in the middle and build what's called a slope chart, which just hones in on the power of position, angle, and slope to very, very clearly show data. The story is very clear. Pizza Hut used to be the dominant pizza chain, and now it's just scraping along above Domino's, and Domino's has gone up, but it's really the other pizza chains that have grown the most over this 10-year period. So as we go through that example, we've gone from a table to a bar and bar chart, to a line chart, to all sorts of different things with a slope chart. Each one of these is using these pre-attentive attributes in a slightly different way to answer a slightly different question. And the challenge we all face as analysts is trying to find the most appropriate chart for our own exploration or for the story we're trying to communicate to our organizations. Big challenge is that as you take data out to emphasize one story, you are going to de-emphasize another story. And that's the challenge. It's like a whack-a-mole situation. You solve one problem and another one creates. Every visualization you can build is a compromise. As we'll see later in this webinar series, the power of Tableau is that you can cycle through these charts as quick as you can think of them, and therefore you don't waste any mental energy trying to work out what the best chart should be and then go to build it. You just build the chart and throw away every single one apart from the one that was necessary. Let's have another look at an example of another look at how there are more than one solutions. This is another real-world case. Cole Nussbaum and Affleck, who wrote the excellent book Storytelling with Data, I highly recommend it. She wrote a blog post defending stacked bars. And here's a stacked bar chart showing in red. So the chart shows goal attainment over time. So as time progresses, are the company's goals being met? The red ones are the ones where it's being missed. And you can see it's been increasing, and in fact, over a third of goals are being missed by Q3 2015. It's a great chart. Cole made the point that it highly emphasizes the problem of missed goals. Stephen Few, who used to blog with perceptualedge.com, wrote a blog saying, well, it's not a good chart. The stacked bar chart was not a good chart because the data didn't have a common baseline. Let me just show you what I mean here. The middle bar, which is goals being met, the baseline changes each quarter. So the challenge is, can you tell me is Q3 2014 bigger or smaller than Q4 2014? I actually can't tell. It might be bigger, but because they don't have the same baseline, therefore, said Stephen Few, it's a bad chart. So he redrew this as a line chart, and in this one, everything has the same baseline. And you can see the missed goals going up and the met goals going down. If you get into the field of data visualization, many, many interesting arguments can ensue about what the right chart is. There is no such thing as the right chart. Cole riposted saying, the point of a monitoring dashboard at this organization was to track whether goals are being missed. And as I said before, this was her primary information. This is what this chart needed to portray, missed goals. Everything else was secondary information. So for her purpose, you could get the gist of this information, and that's fine, but you can see this information extremely accurately. These are the decisions we make all the time. Steve Wexler, one of my co-authors on the Big Book of Dashboards, tried to bridge the gap and make a compromise for everybody. He created a diverging stacked bar chart. So the baseline here goes down for goals being met, so we can accurately see what's happening here. And then at the top, we can see what's happening to exceeded and met goals over time. It's always going to be a compromise. It's your job as an analyst to explore the data, iterate, find the different versions of the charts, and work out which best meets your primary goal. Let's bring it all together with something that many people, or some people and many people would support, have said is the best chart ever made. What happens if we have lots of data? So some of you may have seen this chart, some of you may not. This was drawn in 1879 by Charles Minard, and it shows the story of Napoleon's invasion of Russia in 1812, particularly emphasizing the folly of that endeavor. Many people, or Edward Tufte in particular, he said this is the best statistical chart ever made. Edward Tufte wrote some really foundational books on data visualization and visual analytics in the 1980s and 90s, and he loved it because of the depth of story and depth of data in this visualization. So let me explain what is happening here. Napoleon and the Russians amassed an army of nearly 500,000 soldiers at the Russian border in 1812. He marched towards Moscow. And as you can see, the thickness of the line shows the number of soldiers he had. The Russians were adopting a scorched earth policy, starving and killing the soldiers as they went. So by the time he gets to Moscow, Napoleon has already lost over half his army. Once in Moscow, the Muscovites had evacuated Moscow and set fire to the city. There was no one to battle, so there was no fight to be had or war to be won. Napoleon had to retreat. We see the retreat in black, and we can see the path he took. Now, by now, it was very, very cold, becoming the depths of the Russian winter. And at the bottom, Minard encoded the temperature as Napoleon retreated, and each part on the timeline mirrors to where they were on the ground. And you can see things were getting awful. This particular river crossing, Napoleon lost over half his remaining soldiers, and he limped back to the Russian border at the end of 1812 with only 10,000 soldiers left. A true military disaster spelled the end for Napoleon's dominance, but an amazing chart. And it is an amazing chart because it shows 7 different data types, size of army, latitude, longitude, temperature, rivers, in a really beautiful way. It's annotated, you can see the story. It's a deep, deep story using the pre-attentive attributes extremely effectively. Therefore, it's the best chart ever. Or is it? Well, Seth Godin, who's an author of many great marketing books, he said this in an interview once. He said, it's one of the worst graphs ever made. Tufty loves it because it's got really different data on lots of different axes and da-da-da. If you study it for 15 minutes, then yeah, it is worth 1,000 words. But, said Seth Godin, I don't think that's what graphs are for. I think they try to make a point in 2 seconds for people who are too lazy to read the words underneath. Ouch, that's fighting talk. I would offer that Seth Godin is absolutely, utterly wrong. He completely misses, no, what he does is completely generalize the purpose of all charts. If I want to tell you a rich and deep story about Napoleon's march to Moscow in 1812, I can use this. I just told you the history of the story about scorched earth, starvation, Moscow being on fire, cold and death and loss of life. And it took me two or so minutes. But if that's my purpose, to give you a history lesson, then this is an incredibly powerful way to tell that story. But if I'm doing a PowerPoint where I've only got 5 seconds to tell you about the success or the impact of the Russian tactics on Napoleon's army, this is a wholly inappropriate way of doing it. I could dumb it down for the executives and say, we beat the Russians, we beat the French in 1812, 98% of the soldiers died or were captured, only 2% survived. In some ways, it's exactly the same story, but it's aggregated to a super fine level, which maybe an executive just needs to see and then wants to drill down to the data later. This is what you have to consider anytime you are visualizing or exploring data. What is the most appropriate pre-attentive attribute to answer the most appropriate question in the amount of time your audience have to answer it? And if you're only going to give them a summary, can they get to detail afterwards? So we're going to go to questions in a moment. Do feel free to put your questions in the Q&A chat box. But just to recap, we looked at the fundamentals of data visualization. To me, that covers these 6 topics. First of all, what you are doing as an analyst is thinking what is relevant to your audience, whether your audience is yourself or your end users. Pre-attentive attributes are the fundamental building blocks of every chart we build. But not all pre-attentive attributes are made equally. Bar, length, and position, they're the best for accurate estimation. So bubbles kind of don't work. Then we looked at mapping that to real-world data using Star Trek. We also have that example in Game of Thrones, for those of you who are about 20 years younger than me. And then we looked at Pizza Hut and a stacked bar chart example of how you can iterate and find many different examples and tease out different stories just by changing the pre-attentive attributes that we have. With that, I am come to the end of this section. So let's take some questions. So Shazia's Jamil, you asked, would it be better? So this is a question relating to the witchcraft. Let's get the witchcraft. Let me just bring the slide of witches up. You asked, would it be better to use percentage instead of number of trials per 1,000 people? That's actually a great question. As I do this presentation, referring to this measure, I find really hard. It's quite a hard measure to express in words. What if it was just 0.23% of the population? Yeah, that might have been better. I'm going to guess they went with trials per 100 because it made the number itself bigger. If this was 0.001%, that might have been less impactful on the visualization. But I think it's a very good question. It's a hard measure to describe. Joe Wall, you asked, is there any evidence as to whether vertical or horizontal bars are easier to compare and interpret? That's a great question. And it's a great question because I am not aware of any research on whether horizontal or vertical is easier to interpret. What I will say in defense of the horizontal bar chart is that it allows you to orient your text in a way that is more readable. Imagine if this was oriented vertically, then Switzerland might not fit horizontally, and I'm going to have to rotate the labels so that everybody's got to rotate their head like this just to see the information. Good question. I don't know of a definitive answer. Thank you. David Liberati, do you think pie charts are overly abused in today's workplace? Yeah, yes, they are. Pie charts are overly used in today's workplace. I'm just going to Google pie charts and bring this onto screen. Right. So we looked in detail at pre-attentive attributes. One of the things we are not very good at as human beings is understanding the difference between angles. We can see that some of these sections are bigger, but have a look at that one. Even this one. This is just Google. Is orange bigger than blue? Well, the way I have to answer that question is by actually reading the label itself. That seems like a waste of time. I might as well just have the table of numbers sorted. So yes, we see many pie charts. Fortunately, we don't see 3D exploded pie charts very more. I wouldn't say never use a pie chart. I think a pie chart with just 1 or 2 segments is kind of okay, but just don't ever do this. I mean, we still see, this is obviously from an article called Death to Pie Charts, but we still see people using pie charts like this. It's awful. So, David, yes, they are overly abused. They have their place. It's up to all of us to educate people about the perils of pie charts. Right, let me get rid of that awful abomination. There you go. Mustafa, the pizza chart is missing an important element. Mustafa, so you said, did the other pizzas take away from the Pizza Hut? You asked, I'm going to assume you typed that question before we then showed that aspect of the question. It's that aspect of the data itself. So in which case, Mustafa, you get an A star, because the chart shows Pizza Hut and Domino's, but what it didn't show was the rest of the market, which we came on to. And brilliant, well done, because that's thinking like an analyst. Do you have all the data? Does taking data out enhance the story or cheat the story? Great question. Stuart McDougall. From the presentation today, the suggestion is that some of the best methods of presenting data are also the most boring. How do you freshen up presenting methods to keep them interesting but easy to understand? Oh, that's a great question, Stuart. Right. Let me go back to... I wanted my witchcraft chart. Here you go. I've thought and taught and written at great length about the balance between engagement and getting people to actually look at your data, and effectiveness, getting them to understand your data. This is a really fine line to press. On the engagement side, you have people like David McCandless, who created the Information is Beautiful books, and Knowledge is Beautiful. He makes beautiful pieces of work. They draw people into data who would never have been drawn into data at all. But the price of that engagement is, it's very hard to accurately compare individual values. So things like that are good at communicating the gist of a data story, but not the accuracy. On the other end of the spectrum are people like Stephen Few, who wrote, amazing books. Now You See It, Show Me the Numbers. And he really said, forget any frills, do no frills, or just focus on accurately encoding data. In your organization, I would say, for operational purposes, let's say you're monitoring sales, or monitoring HR, or monitoring patients in a hospital, or students. For operational value that your execs need to see, the KPIs, you need to lean towards that functional end, because what they really want is the answers. For reports and charts in shared prospectuses or things like that, then you can bring in the slightly more frilly kind of charts. I do also think, and I'm going to use this as an example, but it's not a very good example. You can format, I shouldn't say boring. They're boring because they're prevalent, but they're prevalent because they're useful. Just subtly using color, reducing the grid lines, taking borders out, and taking things out, I feel, can bring a charming or beautiful simplicity to visualizations. I'll stop there because that is I've written, if you go to my blog, gravyanecdote.com, and look at search for Tableau Design Month, I wrote at length about it there. But I do think it's a very good question. Okay, VJ. So thanks for the question, Stuart. I hope that was a good answer. VJ Chandrasekaran, what is the best approach for data storytelling? Well, data storytelling, if has many answers. Let me go to Menard. Hopefully, you felt I told a good data story with this chart. This is one approach. What I did was use a pointer to draw attention to the part of the data I wanted you to see at any relevant moment. If I just kept this on screen and went, Napoleon marched to Moscow, and then he got to Moscow, and then there was no one to fight, and then he retreated, and at this river, everybody died because it was really, really cold, then that's bad data storytelling, because the point of data storytelling is drawing attention to the part of the data that is relevant at the time, at the moment that that part of the narration hits. So I can tell a story with a single slide, or I can animate different parts of the story and highlight different bits of it as I get to the different narration points. In Tableau, we have a feature called Story Points, which allows you to build a sequence of charts. You can either highlight, they can be distinct charts, or the same chart repeated, but with different aspects highlighted. And you can use that to actually tell a story and then interact directly. If you're not there, sometimes I won't be there to tell you the story. I need to share the data with you, and you need to find your own story. In which case, you need to think about how do you guide your audience through the story. Maybe you build steps so that they go from A to B to C themselves, or you do annotations like 1, point, look here, 2, look here. So the thing about data storytelling is thinking about how you draw attention to one particular part of the data at any particular moment, and how that forms into a narrative. I hope that answers the question. I also recommend Cole Nussbaumer's book, Storytelling with Data. Very good example. All right, we have 3 more minutes and about 6 more questions. So let's see if I can get, we've got loads more questions. So I'm going to go quicker. Irina, enjoyed the story on Moscow. Do you think there is a tendency for people getting tired of classical charts and looking just for bright pictures and just one number? Oh, that's a great question. Is there a tendency of people getting tired of normal charts and looking for just bright pictures and just one number? Yes, absolutely. Tableau's got an incredible community of bloggers doing crazily creative things and creating elaborate charts, and they get lots of traction, and they are super talented people with creative ideas pushing Tableau to the limits. There was a thread on Twitter just yesterday where somebody, Elijah Meeks, I think, from Netflix, said, he's sick of Sankey charts. Sankey charts are a particular chart type to show flow. And one of our Tableau bloggers, I believe it was Curtis Harris, said he almost regrets sharing his tutorial on how to build Sankey charts, Sankey diagrams in Tableau, because now he sees them misused all over the place. We as human beings are attracted by shiny things. You know, this is why Instagram has got so popular. We like shiny dashboards. We like, woo, look at that. But if we're not looking at it and thinking, are we getting the insight that we need to, then that is a problem. And certainly within business, within organizations, in charities, we've got to communicate the information. So again, I say lean against the shiny stuff and focus more on the effective stuff. All right, Julia Freiberg asks, what about the cognitive load when you have a bar chart combined with a line chart? Does the two strong visualization compete, or do they emphasize each other? So Julia, I guess your question is, can you put a bar on a line and it be effective? Sometimes it might be, sometimes it won't be. I think you have to be the arbiter of that. But knowing that you can ask that question of your charts yourself is fine. If you're doing your own exploratory analysis, you'll be throwing these things around and it will all make sense. But when you share it with somebody else, they won't have the contextual knowledge that you have when you build that chart. So my answer is it depends, but these are the questions you can now ask yourself when you're building these charts. Coburn, oh, we've run out of time. Gosh, I am going to have to stop there. Right, I'm going to take 4 of these very quickly. Coburn Lee, what's your view on a 4-way Venn? Probably not great, right in the circumstances. Lubov Dordery, I'm sorry if I've got that name wrong. When would you recommend using a bubble chart? In almost no situations. Bubbles are generally not great. There's almost always a better way of doing things. And yeah, and then as Samad, you said, that's a great question. Does Tableau have an ability to suggest which pre-attentive attribute best suited to the project, best suited to the data? Yeah, actually, if you look in Tableau, we have Show Me on the left-hand side. That is a rule-based system which emphasizes, which is based on whether you have dimensions or measures, and chooses the best chart according to the type of data you selected. Also in Tableau, you might notice that the row shelf and the column shelf is the biggest shelf you have available in Tableau. And the reason for that is that they are the most effective visual attributes. When you look at it, I'm just trying to open Tableau. When you look at the mark shelf, that's smaller. Let me just show you an example. All right, here we go. So this is Tableau for those who haven't seen it. Show Me, this is rule-based. It's not AI-driven, but it is rule-based. It's saying what dimensions and measures are selected. And then the column and row shelf are bigger for a reason, because they are the most effective ways to visualize data. Color, size, path, they're good, but they're less effective pre-attentive attributes. So Tableau is designed fundamentally to help you make those decisions correctly. As other people in your organization use data and create data sources, Tableau also has an AI, machine learning driven recommendations algorithm to help you get to finished charts and dashboards that other people have built more quickly. Right, I'm afraid, everybody, that's it. There are a few questions I didn't get to, but I would like to thank everybody for the questions today. Let me get to the end. Yeah, keep the conversation going with me on Twitter. I'm Cotgreave on Twitter. I'd love to engage more with some of these questions. I do hope that's been useful. I fell in love with the science of data visualization and visual analytics 10 years ago. It's been an amazing thing to learn about. Wherever you are, I hope you have a fantastic rest of the day, and that this has helped you on your journey to being a data analyst. Have a good day. Thank you. Goodbye.